So now we're going to put some pieces of the fundamental theorem of calculus together, okay, with a little bit different application. So the integral, let's see, let me get a pointer. This integral is this shaded area, okay? And remember the derivative of this integral of, well, why don't I just show you derivative of y? That'll make it easier. So the derivative of y is just f of x. So the derivative is just not the area, but this dark blue line. So if I asked you what's the derivative, what's y prime of 1.5, you would tell me it's about 0. What's y prime of, no, remember, y is the integral. The derivative of that integral is this. So if I asked you, let's see, maybe I better write that out. So y prime of 1.5 is the same thing as f of 1.5. And I don't know, I'm guessing here. I think it's about 0. Okay, what's y prime of 3? Well, that's the same as f of 3. And if we go up, it looks like to me like that's 1. So do you see how that works? So now what I'm going to ask you, what this says, over what intervals is f positive? Actually, what's even better, when is y increasing? When is this integral increasing? When is the function y increasing? And what we have is this graph to look at. So here's that. And we know the derivative of this is f of t. So wherever the y for this function is positive, we know the integrals are increasing. That's what they're trying to ask you here. When's f positive? Well, it's a positive from about 1.5 until about 3.25. Okay, no, we're not talking about the area. We're talking about just the blue line. Okay, when are the intervals negatives? And now we're looking for when is the blue line below the x-axis? So it's from 0 until about 1.5, and from what, 3.25 to about 6. So y would be decreasing because y prime is less than 0, right? So when are the minimum values of f? Over which intervals is it equal to 0? Well, the only place that this derivative is equal to 0. Don't think about the second derivative. Remember, that would be the second derivative. When is it equal to 0? Well, it looks like it's 0 at that endpoint. That's questionable whether we want to talk about endpoints. But it certainly is 0 there, and it certainly is 0 there. Okay? What are the maximum minimum values of well, let's see. I wanted to ask you why. When does it have a maximum minimum value? Okay. So what we want to do is think about, remember back when we talked about the extreme value theorem, said we had to test the endpoints. We also have to test the critical values of when the derivative was not defined, okay, or when it was equal to 0. So fortunately, this function, this f function, is defined every place. Now, the derivative of it isn't defined every place, but certainly the function is defined. So the two endpoints, 0 to 6, and then we also have those two critical values. So what we want to do is we want to think about, now we're talking about the derivative. All right, so let's draw a number line. So then 0 to 6 is and then we get those critical values of 1.5 and 3.25. Let's come back, somehow I hit the wrong thing. So then, is it still recording? Yeah, okay. So then I don't have an equation of plug values in, but I can certainly see that between 0 and 1.5, the derivative is negative. And then I can see between 1.5 and 3.25, the derivative is positive because the blue line's above the x-axis. And then the derivative is negative again from 3.25 to 6. So a potential minimum, certainly a local minimum, because the derivative is changing from a negative to a positive, and this is a potential maximum because the derivative is changing from a positive to a negative. Now, they aren't asking us for absolute max-mins, but maybe we should explore those because that will come up. So what we did back when we did use that extreme value theorem, we found, actually, we want to find y, don't we? So we tested our endpoints and our critical values. So thinking about this first part, the integral from 0 to 0 of f of t dt, well, remember when those bounds are the same, there's no area, so that's 0. Then we're going to find the integral from 0 to 1.5 of f of t dt. And I see a triangle with a base of 1.5, a height of 1, and it's going to be negative, of course. And so 1/2 the base times the height is going to be negative 0.75. Now I'm going to test at 3.25, so I've got that area. Now I got to figure out this area. I don't know. I see a trapezoid. I see a trapezoid with, so 1/2, the height's 1, times base 1, which is, let's see, 0.5 plus so 1.75, plus 1, base 2 is 1, right? Base 1 plus base 2 times the height divided by 2. So what is that? That is 2.75 times 1 divided by 2. What is that? 1.375. So 1.375, and then of course the endpoint. Well, let me ask you this. We want to know the maximum and minimum values. Do you see that whole negative area? That negative area is a lot bigger than 1.375. So I know it's going to be a minimum. Now maybe we got to find it because maybe it's smaller than negative 0.75. Okay, I'll do it. So 2.75, it's another trapezoid, right? 2.75, and that distance is, I don't know, I guess it's 1 times the height of negative 2 times 1/2. Well, those cancel out. That gives me negative 3.75. So it's a good thing I did that. So when's the maximum and minimum values? The minimum value is happening at x equals 6. So that's the negative area, and the maximum value happens at 3.25, and that's that value. So that's work we've done already, just applied to the using integrals. Now for the very last part, what's the average value of f? So now they're looking for the average value. Let's see, what can I delete? I don't want to delete everything because I really want that thing down at the bottom. But let's see if I can delete some of these to clean it up a little bit. So do you remember how, I don't know if you just watched my video or if you watched the video, but to find the average value of a function, it's 1 over b minus a times the integral from a to b of f of x dx. So we just found this, right? So the integral from 0 to 6 of f of x is equal to dx is equal to negative 3.75. And we're going to divide that by how wide that is. Well, that's 1 over 6 minus 0. So that would be 1/6. So I'm not going to do this. I don't have a calculator. But the average value of that f function n of the integral is going to be negative 3.75 divided by 6, whatever that is. Okay, so that's how you can find that average value when you just got a graph and they're asking you to apply those ideas. So hopefully this helps. 162, 163 are all great questions to try and be great things to post in the discussion forum. In fact, maybe I'll make those be seed questions in the forums. Oops.